Bismillahirrahmanirrahim. Dear students, welcome to the course of Introduction to Biomathematics, course code BGTE104, lecture number 8. In this lecture, we will try to discuss quadratic equations. In this lecture, we will go through the following points. Number 1, definition of the quadratic equation, roots of the quadratic equation. Number 3, solution of the quadratic equation. So there are three ways to solve quadratic equation. Number 1, quadratic formula. Number 2, factorization method. Number 3, completing square. What is quadratic equation? Quadratic equation is a polynomial of second degree. For example, the given mathematical form ax square plus bx plus c is equal to 0 is the general form of the quadratic equation. Here x is the variable where a, b and c are called constants. The coefficient of x square, that is a, should not be equal to 0. If a is equal to 0, this equation becomes bx plus c is equal to 0, which is no more quadratic. Now what is meant by quadratic and roots of the quadratic equation? Before going to define roots of the quadratic equation, what is meant by quadratic? The term quadratic comes from quad, meaning square. It means that the highest degree in the quadratic equation is equal to 2. For example, y is equal to ax square plus bx plus c is a simple quadratic function in which the highest degree of the variable is equal to 2. Similarly, ax square plus bx plus c is equal to 0 is the general form of the quadratic equation in which a not equal to 0. Here is a simple example: 5x square minus 3x plus 3 is equal to 0. In this equation, the coefficient of x square is 5. So comparing with the general form of the quadratic equation, we get a is equal to 5. And similarly, the coefficient of x is minus 3, and in the general form of the quadratic equation, the coefficient of x is b. So b is equal to minus 3. And similarly, the remaining constant c is equal to 3. So if we put a is equal to 0 in the general form of the quadratic equation, we get bx plus c is equal to 0. So that's why we write a not equal to 0, because the quadratic equation transforms to a linear equation in single variable. Now what is meant by roots of the quadratic equation? A real number alpha is called a root of the quadratic equation ax square plus bx plus c is equal to 0 if a alpha square plus v alpha square plus c is equal to 0. In other words, we say that this alpha satisfies ax square plus bx plus c is equal to 0. X is equal to alpha satisfy the equations ax square plus bx plus c is equal to 0. It means that x is equal to alpha is the root of the equation. In other words, alpha is known as 0 of this equation. Here we present some more examples of the quadratic equations. Number 1, 2x square plus 5x plus 3 is equal to 0. Comparing this equation with the general form of the quadratic equation, we get a is equal to 2, b is equal to 5, and c is equal to 3. In example number 2, x square minus 3x is equal to 0. This is a more tricky example. Here, the coefficient of x square is 1, so we get a is equal to 1. and the coefficient of x is minus 3. So comparing with the general form of the quadratic equation, we get b is equal to minus 3. But here c is absent, so we can write just c is equal to 0. In example 3, 5x minus 3 is equal to 0. Here the coefficient of x square is 0. So in a quadratic equation, when the coefficient of x square is equal to 0, it remains no more quadratic. And so 5x minus 3 is equal to 0 is a linear equation. Hidden quadratic equations. The standard form of the quadratic equation is ax square plus bx plus c is equal to 0. Here we present a table in which 4 different examples are given in column 1. The first example is x square is equal to 3x minus 1. To transform this equation to the standard form, we have to shift 3x minus 1 to the left side of the equation. For this, we have to add minus 3x plus 1 in both sides of this equation. So the standard form of the equation is x square minus 3x plus 1 is equal to 0 as given in the third column. The coefficient values a is equal to 1, b is equal to minus 3 and c is equal to 1 are calculated by comparing this equation to the standard equation ax square plus bx plus c is equal to 0. In the second example, 2w square minus 2w is equal to 5. To transform this equation to the standard form, first you multiply 2. So 2w square minus 4w is equal to 5. Now to shift 5 to the left side of the equation, we have to add minus 5 in both sides of this equation. So 2w square minus 4w minus 5 is equal to 0 is the standard form of this equation. The coefficient values are computed by comparing this equation to the standard equation ax square plus bx plus c is equal to 0. In the third example, z into z minus 1 is equal to 3. First we multiply z with z minus 1. So we get z square minus z is equal to 3. Now to transform this equation to the standard form, we have to shift 3 to the left side of the equation. So adding minus 3 to both sides, we get z square minus z minus 3 is equal to 0. The coefficient values a is equal to 1, b is equal to minus 1 and c is equal to minus 3 are calculated by comparing this equation to the standard equation given above. The last example is 5 plus 1 over x minus 1 over x square is equal to 0. To transform this equation to the standard form, multiplying this equation by x square throughout. So we get 5x square plus x minus 1 is equal to 0. The coefficient values a is equal to 5, b is equal to 1 and c is equal to minus 4 are calculated by comparing this equation with the standard equation ax square plus bx plus c is equal to 0. How to solve a quadratic equation? So quadratic equation can be solved by three different methods. Number 1, by factorization method. Number 2, by completing square. Number 3, by quadratic formula. So quadratic formula in which x is equal to minus b plus minus whole square root b square minus 4ac divided by 2a is the solution of the quadratic equation ax square plus bx plus c is equal to 0. Here the two roots minus b plus b square minus 4ac square root divided by 2a is denoted by alpha, and minus b minus square root b square minus 4ac divided by 2a is denoted by beta. Discriminant. B square minus 4ac is known as discriminant. It is normally denoted by a capital D. With the help of discriminant, we can judge the nature of the roots. For example, if d is greater than 0, then the nature of the roots will be real and unequal. If d is equal to 0, the roots will be real and equal. And if d is less than 0, so there will be complex roots. Here is an example. We have to solve this equation by using the quadratic formula. The question is 5x square plus 6x plus 1 is equal to 0. First we have to compute the coefficient a, b and c. So by comparing this equation with the standard equation ax square plus bx plus c is equal to 0, we get a is equal to 5, b is equal to 6, c is equal to 1. Now using the values of a, b and c in the quadratic formula, we get x is equal to minus 6 plus minus whole square root 16 divided by 10. After simplification, the square root of 16 is plus 4, so we get minus 6 plus minus 4 divided by 10. So first we add, so we get x is equal to minus 6 plus 4 divided by 10. So we get minus 2 divided by 10, which is equal to minus 0.2. And after subtracting, we get minus 6 minus 4 divided by 10, which is minus 10 divided by 10, which is equal to minus 1. So here we get two roots, x is equal to minus 0.2 and x is equal to minus 1. So the roots of the quadratic equation always satisfy the original equation. So to check whether x is equal to minus 0.2 satisfy the equation, we have to use x is equal to minus 0.2 in the original equation. We see that after putting the values x is equal to minus 0.2 in the original equation, we get both sides equal to 0. So it means the original equation is satisfied identically. Similarly, using x is equal to minus 1 in the original equation, the equation becomes 0. So both sides of the equation become 0. It means the equation satisfied identically. How to solve a quadratic equation by using the factorization method? In factorization method, normally we transform a quadratic equation into linear factors. How to find the linear factors? Here I want to present a simple example, x square plus 3x minus 4. Now to find the linear factors, we have to multiply minus 4 with the coefficient value of x square, which is equal to 1 in this case. So we get minus 4. Now we have to find two values. The multiplication of which should be equal to minus 4, and by adding those two values we should get the coefficient value of x, which is equal to 3 in this case. So those two values are minus 1 and plus 4. Now writing this equation in expand form, x square minus 4x plus 4x minus 4. Now taking common x from the first two terms, we get x into x minus 1, and taking plus 4 common from the last two terms, we get 4 times x minus 1. Now taking common x minus 1, so we get x minus 1 into x plus 4. So which are the two linear factors of this quadratic equation? Here is an example how to solve a quadratic equation by using a factorization method. So the example as x square plus 3x is equal to 0. To solve this equation, we take common x from both the terms, we get x into x plus 3 is equal to 0. So the two terms x into x plus 3 are multiplied with each other and are equal to 0. So we have to put x is equal to 0 or x plus 3 is equal to 0. So if x is equal to 0, we get x is equal to 0. And if x plus 3 is equal to 0, we get x is equal to minus 3. So the two roots are x is equal to 0 and x is equal to minus 3. Now, how to solve a quadratic equation by using completing square? Here we present 5 general steps for the general form of the quadratic equation. In step 1, divide all terms by a, that is the coefficient of x square. So to solve a quadratic equation by completing square, the coefficient of x square must be equal to 1. And step 2, move the number c by a to the right side of the equation. So the constant term should be shifted to the right side of the equation. And step 3, complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. In equations, normally we add or subtract values on both sides of the equation to balance the equation. And step 4, take the square root on both sides of the equation And step 5, add or subtract the number that remains on the left side of the equation to find x. Here we present a simple example, that is x squared plus 4x plus 1 is equal to 0. How to solve this equation by using the completing square method? We have to move to step 1, and step 1 we have to make the coefficient of x squared is equal to 1. So no need to use step 1 because the coefficient of x squared is already equal to 1 in the original equation. So we move directly to step 2. And step 2 we have to shift the constant values to the right side of the equation. We get x squared plus 4x is equal to minus 1. Now in step 3 we have to complete the square on the left side of the equation. So we have to add the coefficient of x divided by 2 whole square value on both sides of the equation. So by adding 4 to both sides of the equation, we get x plus 2 whole square is equal to 3. Now to find the value of x, taking square root of both sides in step 4, we get x plus 2 is equal to plus minus under the root 3. Now to find the value of x, we have to subtract 2 from both sides of the equation as given in step 5. Thank you all for watching. All the materials in the slides are provided from the given link.